about Jonathan. He works for TEDkit, where he's a core member of the team, building an application-aware networking platform that works for any workload and for any environment. He is active in the Java community and is the organizer of the Barcelona Java user group and co-founder of the JBCN conference in Barcelona. Jonathan previously worked at Red Hat as a senior software engineer in the application services area. He is a PMP certified project manager and has been a much sought after speaker at the Barcelona JUG, Madrid JUG, Oracle Code One, DevNexus, and the DevConf.us. So he's very interested in simulated reality, psychology, and Java, along with management technologies. So very interesting speaker. So Jonathan, it's a pleasure to have you on the webinar. Thanks for taking the time out.
Okay. Well, it's a pleasure for me to be here and be invited to share my little knowledge with all your community. So thank you very much for being here, and I hope I will give you a bit of an introduction to Kubernetes operators, and especially in Java, because what we have usually is that we have several operators or objects that we create in Kubernetes, but usually we tend to use Golang for creating them. Also, I have to say that I recently joined a company and I'm not using Java anymore, so I'm using Golang. But I was working with several operators in my former company using Java. So I will share with you my experience with that. So let's put in context what this presentation goes about and why I decided to create this presentation. Well, in my former company in Red Hat, we had the need to create an operator. I will explain it later what it is an operator. But for the moment, just think about something that apparently will make things easier when we want to deploy things in Kubernetes. So I started checking, okay, which are the tools and the languages that we can use in order to create those operators. And apparently everything was related with Golang. Well, basically because Kubernetes has been created using Golang, a lot of content is using Golang. But I said, okay, so do we need to learn Golang in order to do those operators? What about those teams that are experienced in Java? They need to move to Golang. It's not, I wouldn't say it's a super complicated path, but to create a simple thing, learn a new language and a new way of doing things, it appeared too much for me. So what I did is to explore if Java was a possibility in order to create things for Kubernetes. And in my, while I was experimenting and learning, this is the presentation that summarizes more or less what my experience was. I'm going to cover a basic knowledge about what Kubernetes operators are. So, well, sorry for those of you that already know what are Kubernetes operators, but I think it's important for all people just to have a basic context about it. Okay, so, well, one thing, this little mouse was like very important when I was a kid, Mighty Mouse, and because he was always saving humanity from the evils. And in this case, Kubernetes operators and Java saved my life at that moment because I didn't need to learn Golang at that moment. Life, you know, it's always very surprising. And now I'm learning and using Go in my daily work. You never know. So basically, this is the content of my presentation. You have already introduced me very well. Thank you very much for giving all that context to the audience. But I will give you a bit, probably duplicated information, but then what can you expect of this presentation? Because I always want to start my presentations putting exactly what you can expect. Because as an attendee for several talks, I experience sometimes that you go to a presentation with an expectation, with an expectation that it is not real. So let's put it at the very beginning, and then you can adapt your mind to the real context. So second is, okay, I will talk about technical things, but exactly which is the problem that we want to solve. Because in the end, technology, it's a tool, it's a way to solve real problems, almost always. So exactly which is the problem that we wanted to solve and why then? We thought that operators were the way to go. Obviously, I will tell you, okay, explain what are Kubernetes operators, and then the different phases. So how to create an operator, okay, how to test it, and then another thing that it is how to publish it. Sometimes you deliver your artifacts to your customers by internal ways, but operators allow you to publish that content in public, let's say, marketplaces. So apart from the publishing the operator, I will also show you which is the execution process once you have everything created, everything published. Okay, and now what? So your customers or your users that want to install that operator, which is the usual execution process that they are going to follow. In the end, some references that you can use, and it's an important one because the way that I created my operators, and now you can do it with a more easy way. So wait until the end, because I will show you a nice library that can make your life way easier if you want to create operators. And finally, well, thank you and goodbye. So basically, who am I? Well, I started with the brother of this computer. So this was my first computer around 1986, more or less. And yeah, I didn't use Golang or Kubernetes for that machine, but I have to say that probably I enjoyed way more than what I enjoy today with my current laptop. So here you have the ways to contact me if you have questions, if you have feedback, if you want to check my blog post where I have several posts, well, about this talk, also about Quarkus, also about test containers, testing Camel, well, several blog posts that you can find interesting. Also, my GitHub account where you can find my personal projects and also the project that I was working on Red Hat. Well, I'm Java champion. Also, I'm co-leader at the Barcelona Java user group since 2012, so more or less since the beginning. I'm also co-founder of the conference JVCN Conf. It's a conference that we host here in Barcelona for around 800 people during 3 days. I'm software engineer at Tetrate. And basically, now I'm working using Golang, Istio, Service Mesh, Envoy, and that kind of environment. I've been working for Red Hat, also Ocado Technology, and NetCentric. These are the last companies that I've worked. There are several more, but well, only those are the last ones. So let's focus. What can you expect of this presentation? As I said, this is my experience working with Kubernetes operators in Java. So I will show you what was my experience, and I don't try to teach you anything. So it's better if you can experiment by yourself. But definitely, I think if you are going to experience, to experiment with this, the knowledge that you can find here can be helpful. It's an introductory knowledge, so I'm not trying to go very deep into the different details about an operator or the libraries that I'm using. Just simply to give you a context, and I expect that at least I can light spark of curiosity on you in order to explore more. If I do so, I will be more than happy. And as I said, this is not the way. I expect that you experiment with this and find your way to do things. So what's the problem to solve? So basically, we had a tool, an application that was having an API and database, blah, 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 several elements that we wanted to publish in Kubernetes. You can create those text files or YAML files defining what are you going to deploy, okay? So a deployment, a volume, a service, all the elements that your application needs. So you can have like a list of files you execute from the command line, plus you have it in Kubernetes. But if you want to help your customers or your users, internal users, in order to do it more easily and also with several validations, this is one thing. Another thing, you want to have something that incorporates automated tasks, in order to do special things when you upgrade your application. For instance, every time that you upgrade an application, you need to change the image of your pods, obviously, but then probably you need to do some things before, I don't know, database backup, killing one pod, sending a message to somewhere to register that upgrade, several things. Well, so you need something that controls the upgrades. Also, you can have that you want more control. So let's imagine that, okay, you want to adapt your pods considering, have a look at these pictures. Sorry, my phone wants to talk. So let's imagine that you want to do special things depending on the environment. I assume if the cluster has more memory, the cluster has more space, then what you want is to react to that and then change the resources for your pods or change the size of your persistent volumes, whatever. So either you have one person that is checking the system every time and doing manual tasks, or you have something that reacts to changes in different objects on the cluster. So we have several things. So one is easy to be installed. Another one is to to do complex tasks automated. Another one is what happens if pods fail, health checks fail, several things that can go wrong, and you want to do special flows when something fails. Well, you need something that controls all those things and react to those changes. And also, if you want to have more control in terms of metrics, so about, okay, let's get metrics about the whole context of your application. Also is a way to encapsulate your application. So it's like you don't have several files or one super big file with several things that the user need to modify in a text file, whatever. So there are several things that, well, that can help you if you have an operator. And also, operators are related also to Operator Hub, that it is a place that you can publish your operator and users can simply say, okay, I want to install this operator. If you are using OpenShift, you can do it on using the UI, and it's very intuitive, 3 clicks and that's it. Or if you do it manually, well, it's a command, and then everything will be installed and the controller will start taking care of everything. So now you see what's the problem that we wanted to solve. In fact, we wanted to have all those things. So we wanted to have an easy way to install, so the Operator Hub. Also, we wanted to control upgrades. Also, we wanted to be able to auto-tune our application considering the context of the environment where they are installed, and also have a way to react to errors in order to do different flows. So, okay, we decided to go to operators. And then, what's an operator? Well, basically, an operator is an extension of the Kubernetes API. So, Kubernetes API has deployments, pods, services, and so on. Lots of objects. But it doesn't have the object, I don't know, pet store. So that concept of a pet store doesn't exist in Kubernetes. So let's imagine that I want to have this definition of a pet store that implies that it will have an API, a UI, a database, and several objects surrounding all those operands, okay? So what I define is the definition, so the custom resource definition, CRD, that defines what a pet store is. So once we have that pet store definition, at this moment, we don't have anything, right? So then what we can do is just simply create an implementation of that. So I want to have the pet store in, I don't know, in Bangalore, for instance, another pet store in Bombay, and another pet store in Chennai. 3 implementations. What I'm going to do is to create 3 CRs. Each of them has different properties, and I will create them in Kubernetes. Okay, so if I do kubectl get pet store Chennai, I will retrieve the definition of that object. That implies, I don't know, how many users it will allow to connect, how many resources it needs, CPU, memory. Also, I don't know, the size of the database, or even, I don't know, security for the database, user, password, blah, blah, blah. So you have all that definition for that pet store. Okay, we have that. At the moment, we don't have anything yet. So we have those objects, but nothing happens. So what we create is a pod, a watcher. In fact, this operator thing is an application that it is simply listening to changes in several objects, types of objects. Usually, what you do is, okay, I want to listen to the changes in my pet store in this particular namespace. So every time that type of object is created, modified, or deleted, our operator, the listener, this watcher, will receive an event, a message. Okay, now it's our responsibility to do what do we want to do. So if we receive that the creation of pet store Chennai has been created, then the operator says, okay, now I need to create a deployment, I need to create a service, I need to create a persistent volume, and I need to create, I don't know, whatever object that we need for our application. So the operator has received this change on the CR and creates all the things that represent your application. So a pod that has your API, a pod that has your PostgreSQL database, a service, persistent volume. Okay, fine. Then the watcher reacts to the creation of another CR of type pet store. Then it reacts and does exactly the same. Okay, I will create all those objects. So the user created two CRs that are text objects, let's say, with the attributes representing your application. And then the operator creates all what is needed. This is also a way of, let's say, obfuscate your application. So as a customer, I don't really care about the particularities of your application. What I know is that I want a pet store. If there are 3 services for 2 deployments, I don't care. That's on you. So, okay, we have that created. But let's imagine that user goes to the pet store Chennai and says, oh, but when I created this object, we were only 10 people. So it created a database for 10 users. It saved space for 10 users. Now we have grown, and now we are 50 users. So what I need is to give more space in order for the application to go lighter. So I go to the definition of the pet store Chennai, and where I put users 10, that it would say regular users number. Now I say, okay, regular user number 50. So what happens is now our operator will receive an update message saying, oh, so you have changed this CR. So you need some kind of changes in the implementation. So what usually happens is that the operator will check, okay, so you have said that you want this new version of the pet store Chennai with these properties. And what I have is this other version. So I need to do what it is needed to change my current status in order to be the desired status. What can imply that? Well, modify, obviously, the application that it is stored, give more space, whatever. This is a process called, well, in this case, is an update, but it's also related with the reconciliation. Also, reconciliation can happen. You can imagine what happens if the user goes directly to the pod or to the persistent volume and changes the size. What it should happen is that your operator reacts to a change in that persistent volume because it's an operand of the operator. So the operator created that object. So it reacts to that object and says, okay, wait a minute. My CR says space for 50 users. You have changed the persistent volume and has given a size that is not aligned with what the user told me. So the operator will change the operands to reflect the desired status. If a pod dies, the operator will react and will create another pod because the only function of the operator is to keep the reality aligned with the desire. That's what the operator does. So if we have said we want this is what we have to have. That's called the process of reconciliation. So the operator checks the real status and compares it with the desired status and does the changes needed. These are the tasks that we have on the right. I hope you have a whole vision about what an operator is. So now that we understand what it is an operator, which is the problem that we want to solve, okay, so we are clear on why, what, and now let's go to see the how. So when we create an operator, there's a table about maturity on operators. There are several levels, so from 1 to 5. This is, well, you don't have to take it as like a message from God. It's something that some people came with, and that's it. So the basic install is the basic behavior. So you use the operator just to deploy something. That's it. And it reacts to changes, nothing else. Then there's another one that is, okay, but what if I want to upgrade my application? Okay, so when you need to upgrade your application, you need to change the image of your pods. So you need to do some tear down of your pods, then change the image and so on. Okay, that's phase 2. What about phase 3? So it's like you take all the application life cycle. So you do backups, failure recovery, and so on. So these are like from the super dumb operator to the super smart one. Okay, this could give you an idea of where you are. So, okay, I need to go to phase 4 and I'm on phase 2. Okay, I see that there are some things that I need to do. That's it. Depending on the level that you want to go, that's the language that you have to use. So if you use Helm, it can help you only on the 2 first phases, but not up to level 5. For level 5, you can use Ansible, Golang, or Java. In my case, what I did is to use OpenJDK 11, fabricate Kubernetes client, because in the end, it's a Java application that needs something to connect to the Kubernetes API. You could use it with a REST client, but it's hard. You can use fabricate, that it's already giving you lots of things and lots of typed methods and objects. Jeep to create the containers, and Quarkus as the framework that helps us to create something that if we want, we can go to Java native. That, well, in that case, you reduce dramatically the memory consumed and the size of and the time that the application will take to start. So it's, if you can go to native, definitely is something to consider. Tools that I used, well, kubectl to connect to the Kubernetes cluster, or OC if you are using OpenShift, but you can use kubectl also with OpenShift. Dive if you want to see what your image contains about the layers and the files for each layer. In this case, Podman instead of Docker. The registry is where you store your images. So you can store them in Docker Hub or in Quay. So I was using Quay. And as the local cluster, so you can have a Kubernetes cluster on your local machine. There are several options. Two that are very famous are Kind, Minikube, but you can also use 3KS and also Microx. So there are several ways of having a Kubernetes cluster on your local machine with a monocluster. So when we create an operator, well, we are going to have a Java application. In this case, I used Quarkus. And then what we need to create is, well, which are the security elements of our operator? Okay, so in the end, you need to say to your operator, or you need to configure your operator with permissions to react and to have access to which objects in the cluster. So you can define your operator that is cluster-wide or is namespace, depending. If you want your cluster to have, your operator to have access to all the namespaces, but then you have to give the operator cluster-wide access. Then the CRDs. So CRDs are the definitions, the pet store definition that I already showed. And the objects are, well, cluster-wide, we have the CRD and the namespace, obviously. And then we have namespace-wide, we have our service account. Service account is like the user credentials that the operator will use to interact with Kubernetes, right? And this service account will have some permissions. These are defined in the role and role binding. So you can say, okay, this service account allows who uses it to access pods in order to list them. But then that service account cannot do a get on a pod. So you need to configure which are the permissions that you want to give to your operator. In this case, the service account that the operator will use. Then you need the client to interact with Kubernetes. That's, in that case, what we are going to have are 3 beans in Java. One is the namespace that we are going to reuse everywhere. The Kubernetes client, that it is like a general approach client that can be used to retrieve non-typed objects, and the CR client, where we have a client that it is expressly created for our pet store definition. Then we have a watcher on those CRs and another watcher on the operands. As I said, if someone goes to the deployment and changes something, the operators should revert the changes. So we need a watcher on those objects. And then these are the commands in order to build, push, and deploy our operator. We use Maven, and as we are using Quarkus, we simply say, okay, we are going to create the package. Also, we are going to use native with GraalVM, so it's going to create an artifact that can run without JVM. And these are the properties also to specify that we want to use Graal downloaded from the registry, and that we are going to push the resulted image to our registry. And finally, we are going to apply the deployment of our operator this way. This is the manual way of deploying. So now there's a thing that it is not very funny, but yeah, we need to use YAML. So those YAML files are going to define several objects. Okay, we will see now. This is the structure of our project, our Java project. So we have controllers that are going to react to those changes. So we have one, in this case, WindUp was our pet store. Okay. WindUp controller and WindUp deployment controller. So one is reacting to the CR and one is reacting to the deployment. Then we have different definitions. So what we have is, okay, this WindUp or pet store element, which is the definition. So which are the elements, which are mandatory, which are the types when you need to define an object of type WindUp or pet store is the same. And finally, beans and clients to operate with Kubernetes. And on the right, we have those elements that we need to define in YAML. So we need to define the CRD, we need to define the deployment, the namespace. All these objects are going to be used by the operator or by the deployment process when we want to deploy in a public market. We will see later. So on top, we have those YAML definitions, and below we have the files when we want to deploy to the operator market. Well, so these are more or less the files. Don't take a deep look at them. So you can just check these slides after the talk, and then you can put all your focus there. But now what is important is, well, a CRD is a YAML that is defining a type, custom resource definition. We define if, that our objects are going to be namespaced. And as you can see below, we have OpenAPI v3 schema, where you define exactly which is the definition of your element. In this case, we have two properties: host name HTTP, that it is type string, default empty, and volume capacity, that is type string, default 20G. So you can define your pet store, and here you would put, okay, city, you would put memory resources, you would put CPU resource, you could put volume size, all the things that you want to, that are going to serve you to define your application. Then we need these files, the role and role binding, that and the service account, just to give permissions to the operator to operate inside Kubernetes. in this case where we are specifying in which is the namespace, which are the elements and the operations that this role is giving. As you can see, okay, you can for the deployments that are belonging to the apps and extensions API groups, you can create, delete, get, list, and watch. If I remove create, delete, and watch, then the operator is not going to work, because one of the main things is watch. So it needs to have the watch permission. Role binding is simply something to connect the role with the service account. That's it. And finally, the deployment. So this is the deployment for the operator, where we specify, okay, which is the image of the operator, the pool policy, the environment variables that it will use. Well, it's a basic deployment for any Kubernetes application. So regarding the objects that you will use in your code, basically what you need is, okay, we are going to create a bean that it is a default Kubernetes client. Okay, and we can use this default client to interact with Kubernetes. Then we are going to have a CRD specific client. So the objects that are going to accept this second client are only those pet store objects. And then we are going to create this CRD context and for using the CRD. That's it. And then another being that it is, well, the namespace that we can reuse somewhere, anywhere that we use the namespace. As you can see on top, that we inject a namespace bean on the parameter of the make CRD context. So these are the clients, let's say, that we will use in our application, our operator. And then what we have is, we have an operator that, as you can see, in this case, it has an on start. And when the operator is, so when the application starts, it creates a watcher, okay? And it passes the control to the class WinApp controller, and also adds another watcher for the deployments. And it passes the control to the deployment WinApp deployment controller. These controllers have three methods: on add, on update, and they can do on delete too. And you decide what you want to do on all of those cases. So on add, okay, on add you need to deploy everything, right? So create the deployments, create the services. On update, okay, you need to update your objects and check the status. Okay, so that's basically it. In this case, we are checking if the deployments ready are 3, because this is a requirement. Then we update the status. That's it. The same as with the deployments watcher. We will do our logic there. And the reconciliation process is, as I said, okay, when something changes, I need to update and override the content of all our pods, deployments, services, in order to be what they should be. And this is also something that you will do in the logic of your reconcile method, that it is called by the events that we saw before. So once we have this Java class with the watchers and with the methods in order to do everything, okay, now we have something that if we put in Kubernetes, it will do something, right? But we need to do also some tests. Okay, about the unit tests, there's nothing I have to tell you. It's a simple Java class, so nothing to mention here. Regarding the integration tests, okay. So what if you want to test your operator, but you don't want to each time start a minikube, a cluster, deploy everything, test, check that everything works? Well, what you can do is just to simply mock Kubernetes. So for that, there's a Kubernetes mock server object that we can use. And our application, our client will send all those API requests to Kubernetes, but instead of a real Kubernetes, it will be a mock Kubernetes. So there's a mode where you can just simply set that it will respond with automatic responses. So every time that something you update something using the client, it will send a request. Then the only thing that you need to check is that, okay, my Kubernetes cluster, did it receive the request that it was expecting? If so, that's okay. If not, there's something that I didn't do. Okay. So this is a very convenient way using the Kubernetes mock server. Also, you can use an end-to-end test. For that, you can have this script that what it does is it compiles everything, it creates the image, and then having a kind local Kubernetes cluster, it loads the image inside the kind registry, creates or deploys everything that it is needed for the operator, and then creates the CR, as you can see here, create the CR to trigger the operator. So once we have everything deployed, then it creates a pet store, Chennai, and then waits for some seconds that everything is deployed. And what it does is, okay, now I'm going to do a kubectl get all, and there should be several objects created by the operator. Then this script is just simply comparing that the number of objects received is exactly what I am expecting. So if everything worked fine from the creation perspective, the operator should create all those 19 objects in this case. If not, something was wrong, and yeah, we need to check. So that's another convenient way of doing a local end-to-end test in this case. You can do exactly the same, but putting that script inside a continuous integration pipeline. So in GitHub or any other, you can have this pipeline, and then every time a pull request is pushed, then this pipeline will be executed, it will deploy everything in a kind, and it will check the number of objects. So you know that no change in the PR is going to break this operation. And test it in a real cluster, okay? No mocks here. So when we have, now we are reached the moment where you know who am I? You know why you are here, what you can expect. You know which was the problem that we were trying to solve, why we decided to use operators. Also, you have a basic knowledge about what it is an operator, how to create or which are the objects in Java that you need to use in order to create an operator, and which is the flow. Also, you know how to test the operator using integration tests or using end-to-end tests, either in local or in a pipeline. So now you would say, okay, now I have everything. Okay, so what if you want to publish your operator in order for your customer just to use the operator, but not asking you for sending them any file or anything. So let's see how you can publish your operator in a marketplace. On the left, you have operatorhub.io, that it is for open source projects. And from there, you can search and find an operator among several operators that are in the website. And then you have instructions in order to deploy easily each operator. If you are in OpenShift, you have the console UI, where you can go to the Operator Hub, embedded marketplace, and then you can search for an operator and then install it directly from the UI. So it's like, okay, you're putting your application in a market, the same way as you are doing with Android, iOS, or any other platform. So in order to submit or files to publish the operator, well, there is a project in GitHub where you need to create a pull request specifying these files that you see on the left. Basically, is the cluster service version, is a file that contains descriptions, also the logo, also the service account, and several files, and also which are the CRDs that you are going to use. So that will be submitted to that project, and then once it is deployed or it is built, approved and built, your operator will appear in the markets. Okay. This is a basic view of the CSV file where you have, okay, which is the container image for your operator, the custom resource definitions where you put descriptions, the deployments and all the files that are needed for to deploy the operator, keywords in order to the user to search your operator, and which are the install modes. So when you install the operator, you can select, okay, one namespace or multi namespace or all namespaces. So you specify here which is the options that are allowed. Basically, this is the way to deploy in a local cluster, or, well, local or remote cluster with OpenShift. So you are simply building the image and then building what it is called a catalog and a bundle. Those images are going to contain your operator, and you are going to deploy this into the cluster, and then your operator will appear, as you can see on the right, in the category that you specified. Then you can install from there your application without having to really publish it and making it public. So you are doing the same test, but in private, right? And the execution flow, it's basic in OpenShift. So when you search for an operator, then you see some descriptions or some information about the operator. Then you say, okay, I want to install it. Okay, specify which is the namespace where you want to install this operator, and then voila, you have the operator in that namespace, as you can see on the last screen. But doing that, let's say that nothing happens. Now you need to create a CR, so that pet store Chennai. So you can just simply go to the same operator page, that the one that you have installed, and then you can see here provided APIs, and you will see pet store. Then you create the instance, and you specified in this UI all the fields for those properties that we configured as part of the CRD. Then also with validations regarding the type, so the user can define which are the properties. And finally, when you say create, the operator will execute, will react to those changes, and finally you will see all the operands, as you can see in the right screen on white, you can see the deployment, the service, the replica set, pod, and all the operands that the operator has created. And finally, well, if you access your application, it is working. So it's very easy for users to just simply install applications and use them. And the operator is running. So if anyone comes here and modifies this max post size or this executor CPU request, then the operator will change everything. That's it. This is the way that I created the operators, but there is a library, a project going on called Java Operator Sdk that has been created, let's say, coming from the Golang Operator SDK and adding functionalities on top of the Java library. I totally recommend you to go there to the main page in order, if you want to create an operator, because they are doing lots of things easier if you use them instead of using this manual way of what I did directly with the client and so on. The Operator SDK just simply gives you lots of functionalities for testing, for scaffolding your operator. So definitely take a look at this library because it will make your life easier. Basically, it has, well, the CRD class that will have an object CR, the operator will have a controller, and then we have the different operands, and what is called an event source, that it is similar to a controller, but for all the operands that the operator has created. So you remember we had a watcher for the pet store and also a watcher for deployments, service, and so on. So these are the two concepts. But they make the coding of this very easy. And here you can see a bit of code. So there are several annotations that imply that a small class will have a lot of behavior. Yeah, it's very easy, just simply using controller configuration, reconciler, and so on. And with the CRD class, that it is the class that will define your implementations, well, you simply annotate an object, and this also will produce the YAMLs that you need. So also it's a way of having a unique source of truth, definitely. And the event source is exactly the same watcher for the operands, as I mentioned before. Well, we've reached more or less final of the presentation. There are several references that you can just check later. So, well, the WindUp operator GitHub project, the one that I created, my first operator, the Kubernetes reference, Fabricate Kubernetes client, that it is a very advanced Kubernetes client that gives you lots of functionalities and power. Quarkus, because I used Quarkus to create the operator. Jeep, in order to create the container images without even having Docker installed in the machine. So that's very convenient. And then Podman, instead of Docker, Minikube or Kind as local clusters, and Quay as the remote registry for your images. And basically, that's been it. I hope it was interesting for you. I hope at least I fired a spark of curiosity on your brain in order to know more about this. And in any case, I will happy to answer your questions. And if you want to contact me and make me questions, suggestions, feedback, whatever, here you have the ways to contact me. That was it. Thank you very much.
Thanks a lot, John. In fact, you did more than spark our curiosity. So we really loved the theory round, the initial theory that sort of nicely set us up for the walkthroughs, and also the way to kind of publish the operator, and then using the Java SDK to do that. So I think really, really useful. And, some of it is like very, very useful for people who want to begin doing these things on their own. And, also loved personally the antique computers, if I may say so. The Emacs and all that. So it's really lovely to see them on your slides. So thanks a lot for taking the time to do this webinar today. And we're already at the top of the hour. So unfortunately, we wouldn't be having any time for questions on the webinar. But yeah, I mean, like you said, I would encourage the participants to reach out to you if they have any questions. I'm really grateful to you for doing this with us, Jonathan.
A pleasure.
Yeah.
Anytime.
So thanks a lot, everyone, for joining us today. Have a good evening. Jonathan, you have a good day ahead.